Hey everyone, welcome back to our vlog on demystifying data and media. And this time around we have a special one. As all the hype around AI and these chatbots, we're going to talk about, do we need machine learning in our marketing and can we use it? So we're here and I think we might be replaced by our AI bot here, but should we ask it a couple questions, Gord?
You think we'll get replaced?
We'll find out. Let's see how good it is at answering some questions. So our first question is, what is even the difference between AI and machine learning?
Oh, let's put it in and see what happens. Between AI and ML.
So machine learning is ML.
And artificial intelligence is AI.
That's right.
So we've got that figured out.
We know this. Hopefully. Oh, I said that. It knows that.
Yeah. Already. We don't have to be here.
So are we done? We don't need to record this anymore?
We could just leave. I would say no. I mean, you have to be able to read this and understand it.
Right. So what do we need to know? So the difference, my understanding, AI, and I used a chatbot previous to learn this, but AI is like an overencompassing kind of field, and then within it is like under like an umbrella, we have machine learning. It's like a subset of AI, if that makes sense.
Yeah, I think you cannot have AI without ML.
Okay.
Or can you? Or is it the other way around?
I don't know. Does it matter? So,
they're very intertwined.
So is this chat, is this ML or AI? And I guess, what is it called? Like this is, we're using a version of GPT 3.5, I think, Turbo, which is based off like ChatGPT's large language model. And GPT is that, which is like what a generative pre-trained transformer, I think it means. And
I believe so.
Is that an AI or ML? Should we ask it that?
Yeah, we could ask it that.
Curious.
Let's see. Is GPT AI or ML, right?
Yeah.
There's your generative pre-trained transformer explanation for the acronym. And it says that it's a language model that uses a combination of AI and ML techniques. So there are different techniques for AI and ML. We're mostly familiar with the ML ones here at Adswerve, I would say.
Okay. So yeah, let's discover that. But I think we need to clear the air on something real quick.
Okay.
Do you remember from our past things, is Green Socks real? Do you own that company? For everyone who remembers our...
Well, we've been getting some comments about that.
Right.
So we did want to clear the air about that. And we don't have to ask Sage about this, but greensocks.com, it was a fictional company. We were using it as an example. So I'm not making a side hustle on that one.
Sounds like it might be a good idea, though.
It could have been a good idea.
Or maybe
it might have been a good idea.
It still is.
We don't know. I guess we'll have to see.
All right.
But we were using it just as an example, just to clear the air. So what do you think? Is there a difference between ML and AI?
I think there's a difference, but I don't think it matters for this purpose. Like it means more of, they're kind of one and the same. Like AI or ML is AI. It's a part of AI, and just need to know that. So artificial intelligence, you train a machine learning model, and it tries to make predictions and tries to maybe do some things like a human. But I think the overall idea of AI is trying to be more like a human, like make systems that are like humans.
Right.
And I guess in some ways, certain machine learning models can actually be better than humans in many cases, processing huge amounts of data and making decisions and things that we can't see potentially.
Yeah,
so
like humans cannot remember everything they've read in their entire life. Let's say I can't. Can you?
I thought you would actually.
No, I can't.
Movie
quotes I can do, but not books.
Okay. Yeah.
But if you feed every book about every subject into the computer, it will know. It'll learn from it. It'll remember.
I'm limited to this size of brain. So like I cannot make my brain go larger, where think of like a computer, we can make these grow out into huge warehouses, and they can communicate at light speed where our neurons cannot go that fast, is my understanding. I've asked another bot to help me out with that one.
Have you been are you in a relationship with a bot at this time?
No, just
me neither.
Yeah, just to know the knowledge or get some information. But anyways, do we need to use machine learning in our marketing?
Right. So that's where we want to focus our discussion today. Is that we could go a lot of different ways. We could sit here and talk to this bot all day long. I'm sure we could dream up all sorts of questions. But we want to ask it specifically, does marketing need machine learning? So if you're running a fictional company or a real company, and you have a marketing department and you want to promote something, do you need machine learning? Like, to stay afloat, to make sales? So, does marketing need machine learning? Let's ask it that. So it says it can be a valuable tool for marketers. It can help them analyze and interpret large amounts of data to gain insight into customer behaviors, preferences, and trends by using ML algorithms. We're not going to focus too much on the algorithms here today.
No, let's keep it high level. You can dive into a lot, and there's whole degrees on this. You can go to university and learn for many years on this topic.
So some of the specific applications of machine learning in marketing include predictive analytics, customer segmentation, personalized messaging, and recommendation systems. So I know that I've seen the recommendation systems on websites.
Right. Or personalization, too.
For sure.
Definitely. Yeah. Like you can use data and then have things be dynamic and pop up on a website that really is personalized to you, and behind the scenes can be a machine learning. But do we really need ML for personalized websites? Like, I've been going to websites for decades and it says, "Hello, Gord." That seems pretty personal. Well, yeah, if you gave your information and you've logged in somewhere. My zero-party data. They might know that. But that's not ML. No, that's just grabbing something from a database and saying, hey, first name, which is Gord, and it would just pop up there. So you don't need machine learning there. Machine learning usually is like you have huge data sets that can train on, find synergies within the data, and then it can understand and predict what maybe it'd be to personalize to you. So custom, if you're a person who's likely to buy something next time, it's these familiar behavior that you're doing like other people who have bought something on a website before, and then it can maybe change that personalization to you because you're like, hey, you look a lot like this other person who has purchased something in the past, so I'm gonna do something similar. Not look alike, same T-shirt, but behavior-wise, your actions on the site look similar, or maybe where you've come from. So the first-party data they've derived from you makes that you look like somebody else. Like, you both like sports, for example. Sure. You both like a certain basketball team, and you're running a clothing store that sells basketball clothes. Yeah. Or it could be as simply you clicked on the same similar ads as this other person, or you came from the same kind of channels. There could be many different ways you could look at that. So I guess we have questions for say I was going to have a CMO, a chief marketing officer. What kind of questions would you ask for, do you need to know for, would you use ML? So it's do you have a large amount of data you need to make sense of? Yeah, for sure. You cannot do machine learning without a large amount of data. And the more data you have, the better your models are going to be. So if you have, a couple Excel spreadsheets of data, that's not going to be enough, I'm going to say. I'm going to say you're not going to have enough. Would you agree with that one? Yeah, it could be bias, right? You could have a small subset of data that just would lead to a totally different result than if you had tons more data to throw at it. And then one question I always like to ask them is, are you trying to predict something based on your customers? Besides, would you like to buy this or not? Or are they going to buy this or not? How would you do that? How do you come up with these predictions? Is that something that you're missing in part of your business? Would that help you make more sales if you're able to predict anything about your customers? So if you're looking to predict something and you have some past data to look at, then I say you could use machine learning. Right. And then others are like, do you want to automate a task that currently requires human interaction? So I suppose like we're seeing the rise of these chatbots. Like sometimes online, you've probably seen the little thing almost like Clippy on the websites that pop up say, hey, do you need help with this? It's like that's a chatbot that maybe not be connected to a real human. That could be kind of a machine learning model. They could one specifically language learning model, I suppose, but that could be on there. But in this case, you would not necessarily use that, I wouldn't think, for marketing.
Do you think you could just have a whole team of these robots to replace a data science team?
I hope not, but probably not. I think you have to ask the right questions, right? And that's the thing is you need to know, like what you said, is like, what are your goals? What are you actually looking for? And like, what are you trying to predict? Or like so you need to know certain things that a lot of these may not know, and it may not be goal directed like you are. So I don't think at this time. We'll see.
And like, I agree with you. I hope that doesn't happen. Right? We'd be in a bit of trouble.
Yeah, but I think we can use it to augment our,
our
work. We can do more now with less. So it's like, do you have a data science team? For example, like would be a good question also to ask. Is like, you can actually use some machine learning models that are maybe on different platforms without having a complete data science team, or Adswerve can help out with that, because like that would be something like we have the data science team, and if someone doesn't have that, they could just come to us and we can help out with it.
For sure. Like not everyone's going to have a data science team of like nearly, a dozen members on our team now, maybe more.
Mm-hmm.
Not every business is going to have that or require that. Or maybe they don't even need a data science team for the entire year. They just need something to set up, get the model working, and then run the new data through to make the predictions.
And then once that model keeps training, it's like, then you don't need the team, or you don't need someone constantly looking at it. The model is kind of keeps learning.
Yeah. And then the final question we have for our CMOs is, you may have a bunch of data, but do you have all your legal basis covered to use that data? Like, are you supposed to be using it for that? That's a very important question. Right. Otherwise, you could be increasing your sales, but you could also be increasing your legal costs.
Right. So do you have to be aware, especially using these other platforms, that you may be sending your own data or proprietary data? You might also want to be concerned with where it's going, right, and where it's processed. Or like, is that data being used to train on something that you're not even aware? And so there's definitely things to look into and make sure you have in order.
So let's say that I was running greensocks.com, hypothetically.
Okay.
Should I go out and get a data science team, or should I?
How much data do you have?
Well, I had a couple years worth of sales. Sales were going good, hypothetically, like the way we described it.
Yeah, they're great.
Until we had that.
Up and to the right, right? That's like, yeah. Okay, well, let's take a look at what kind of offerings we have.
And in this case, we were using propensity models, which scores users, basically a percentage, like 55 out of 100, on their likelihood to perform a certain action. So down across the bottom, it says propensity, or P20 less than. So that means their propensity score was less than 20. And then all the way to the right at the bottom, their propensity score was above 95. The yellow line shows their return rate within 7 days. So you can see as you move higher in the propensity scoring that they are going to return within 7 days. It gets higher and higher, that probability. The difference between red and blue, which is the sessions where the users return within 7 days, versus the total sessions. So in this case, we were looking at how we were trying to predict if a person was going to come back based on the actions they did when they first visited the website. But you can totally use propensity modeling to predict churn, if someone's going to leave your website or not, and when to throw them certain offers to keep them if they're in danger of churning, when they're going to convert, like purchase something or sign up for something. So we've done this with several different subscriber type websites where you have to create an account and you're using their service and you want to build that audience up. So that's what propensity modeling is for. So if you're looking to predict anything, and you want to basically have a probability of a certain users taking an action in the future, you'll want to use propensity modeling, and that's machine learning technique for one of those.
Cool.
Another one that we use is clustering or cluster segmentation. And we've done this for a few clients where we build a model and we look for similar patterns within groups of people or clusters of people. And you want to identify the key points that have the main differences to identify those clusters. So groups of users that have similar behavior, page, like they all, then you can kind of put them together like in a loyalist group, let's say. If they have their profile completely filled out, they come to the site every day, they update their profile picture, you can put all those different behaviors into one cluster. Whereas someone would just come once a year maybe, bounce, they're not going to be the same. They're not going to be part of that cluster. They're not exhibiting the same behaviors. So the technique of clustering can be very good to help identify groups, clusters of behaviors, and then you can, as new people come to your site, you can assign them to these clusters, and you kind of can predict what they're going to do in the future. So does that make sense?
Does. What do you do then with that information?
Well, I mean, if they are a super fan and if they're, let's say they're in the highly loyal group, but they're not completely filled out in their profile yet, you can send them reminders to do that about what the advantages are to do that. You could look at some of the behaviors that fall in the timeline of previous loyal users and then hint at them doing it, so it's giving them a better user experience to do that. Things that these loyalist groups eventually did, you can move that up the chain quicker, capitalize on those revenue dollars, stuff like that.
Cool. Yeah, that sounds great.
So this one here, we were comparing like two factors of time on site and scroll depth, those two points. And when people had a data point plotted similarly or different groups of people, then that would be a cluster of people. So
cool.
Yeah.
What's our next type? Let's see. This
was the customer journey we talked about. So I briefly touched on that earlier, or just previously, but go ahead.
This is another example of, I guess, a customer journey, right? And this is specific to, we're going to talk about an example of what's called data-driven attribution. So this would be like a standard customer journey, or maybe they saw an ad on Facebook, then they click on that ad, come to your website, then maybe the next time they see an ad on Google Ads, go back to your website, they maybe sign up for an email or something like that. Then an email comes to them, then they come back to your website. Then maybe they see something on a display ad on another website. Then they make a direct visit, and then they finally ultimately purchase something. So this is like a customer journey could look at. It takes multiple touches sometimes to see that. So in this scenario with this customer journey, it's like, how do we give credit to, like, which one worked? Do we think Facebook worked? That'd be what's something called like the, kind of a first touch kind of attribution. So we give like the credit to Facebook because that was where they first saw the ad. Or is it the second one, Google Ads? They saw that as the second time. Maybe that worked.
I like the first one.
The first, yeah. So if we go to we'll look at the next thing. Basically, these are the different types of attribution where we have the last click. So it could be the last one, which in that last scenario was, I think, a direct visit. So was it really the direct visit was what worked, or the last click non-direct?
Well, direct visits don't even include a click, right? So it wouldn't even be direct visit.
Yeah, you can measure that with analytics. You'd be able to see that as a direct visit, but you can have last non-direct, which would have been something else, right? And then you could have given the credit to that.
That doesn't seem fair, though.
No, it doesn't seem accurate because you had ad spend, right? In the Google ads, you spent money on ads on Facebook. Another way is like do a time decay. It's like over the time that was there, you give credit to everything along the path. Or maybe linear, you give them all equal. Or position-based, you give credit to the beginning and last. Or just first click, because that really is what got them interested in your brand or website, right?
That's a tough call.
Yeah, it is.
I mean,
it is.
Just thinking here, like I like time decay, but if I didn't know something existed, and then all of a sudden I see an ad for it, and now I know, time decay was really not going to give that any credit, and that's how it all started. Like that's how the snowball started rolling,
really,
so to speak.
It really did. So those are like rule-based is what we're kind of terming that for these different ones. They don't really require much data, or there's not really any machine doing any learning, where we could actually use maybe machine learning for what's called data-driven attribution. So that has all this information about the customer that did the clicking and how they engaged with these different platforms.
Okay.
And what it's doing is using machine learning by crunching a lot of data, training a model to kind of actually give credit to where the most effective solution, and then it's kind of balanced differently. So this is a data-driven attribution to know kind of where to best spend your money and which one is actually working. So you're going to kind of see different ads that maybe had worked better than others, or different platforms that work better than others, and you're going to help inform your business to make a better decision on where to spend your money.
So I guess the question, because we were coming back to it, is like, do I need the ML-based one, or could I just do these other rule-based ones?
If you get to the right metric and you find that like last click, last non-direct is okay, and you're finding like that's acceptable to you, then you could use that. But I think the ML based is probably better to find maybe just signals in the data that you can't see, right? The others are just it's basically just with the rule base is like, well, yeah, first click, you're like, this is what worked for the first click. It's like you might be missing something. So that's something where we can scale up these machines to train them on large data sets that can find stuff that we can't see by using these standard rule-based things. And it'll find us some signals that we maybe weren't aware of before.
Rule-based it's basically assigning the distribution of the credit beforehand, whereas data-driven, the machine is learning how to do that.
Yeah, and it's doing it by data, and again, making these associations that like we might not be aware of, or the rule base is just never going to get you anywhere. It just like is you might know what's effective somewhat based on the rule base, but I don't know if you have as much detail. And again,
it's like we said at the start, you can't remember every book you read.
No.
But the ML-based attribution, the data-driven one, can.
We can let the computers run
as much data as you have
overnight and figure it all out. Yep. So it's definitely very powerful. And another type is this media mix modeling. So this one's kind of important as we go into kind of a world where you might have less granular data on customers. And it's kind of...
Why would I have less? I thought the world's getting more data.
Yeah, we're definitely getting more data. But there's privacy and cookies and changes happening. So potentially you're going to know that you spent money on ads in different places. And there's this thing called media mix modeling, where you can have all these different channels put into like a model, or trained, you're training a model. You can have all these different channels pushed in, and then revenue for each of those channels. And what it will do is try to figure out which channel is actually the most effective. It even takes an account for time. So like you could have like, how long did it take for that channel to actually start producing revenue? Mm. And you can learn then from that where to best spend your money as well. And so we have done this for clients actually, where we can actually do some predictions in. So if I spend $10,000, what can my expected revenue increase be? So in this scenario, like you see here, there's this graph to the right there with the diminishing returns. Like you can see like where if I spent maybe $15,000, I might have diminishing returns where I actually don't even make my money back. But in this scenario, if I spend $10,000, I'm going to actually have an expected revenue increase of 18%, and I'll make $12,000. So that has this what's called marginal return on ad spend. So if that is greater than 1, that is where you want to be for that. So it's actually like, well, I spend the amount of money, but I'll make back more than what I spent. And so you can kind of use this as a prediction in knowing where to spend and then seeing if I spend in this area, how much more can I actually expect in revenue, which is pretty cool. And then over time, you can keep retraining this model and it'll learn and get better and better and better as you feed it more data.
So we're looking for the point that's furthest away from the light blue line, the distance between the dark blue line and the light blue line.
Yes.
That's how much we want to spend per day.
Potentially. I mean, you can kind of do the calculation there, yeah.
Cool.
So pretty cool thing. We've actually built this like as a tool you can play with and interact with, which is really awesome for customers to do this and try to predict where to go and where to spend. It's a really cool feature. And then last, I think we did want to touch on, there's some other things called like lifetime value. So it's like, it's a kind of a metric, but it's like you can, look at the lifetime value of a customer. And then there's predictive lifetime value. So similar to your clustering, where you can cluster a customer into like some predictive lifetime value, like based on their actions, what they've done is like, this could look like, oh, they're going to probably spend this much with us. And they can use that in forecasting or wherever for that. And then another thing.
Yeah, because I could assign a lifetime value to each one of the clusters.
Right.
So
or you'd maybe know that data already. So you
well,
don't even
I could average out their historical purchases and know that people in this cluster have a lifetime value of whatever it may be.
Right.
Okay.
Yeah, you could do that. So and then you can predict on it too if you needed to predict.
Forecast.
Like how much. Yep.
So if I get new subscribers, so if I'm spending money to get new subscribers and I can use this one here.
Right.
Then I can like say, oh, as I get these new subscribers and they fall into these different clusters, I'll be able to predict how much revenue I can get for the next year.
Right.
So then I can have all these machine learning models working together.
Yep.
And just ramp up my business.
You totally could. And then the other thing is like we even have explored like dynamic pricing. So like if you maybe have a website where maybe for like the socks, maybe they have certain times of the year, your winter socks might change in price based on seasonality. So we could have maybe some dynamic pricing that's maybe using machine learning behind the scenes to kind of change that pricing based on what's more likely that the customer is going to purchase.
Or what type of customer that is.
Right.
Where they came from.
Yep.
Not a lot of point in selling wool socks to people in Florida, I would say.
Yeah.
Although wool does retain its insulating power when it's wet, and it does rain in Florida, so that could be wrong. Maybe the machine will figure it out.
Yeah, it actually might know. It's again, it sees some signals that we may not see. We're biased, right? We probably have. So hopefully you can use some of these to remove some of that bias, right? That thought that you have, and see some signals that you didn't realize were there. It's pretty.
So is it fair to say, like, let's say you're running your business and you think you've got a pretty good handle on things, but you're having trouble like seeing where the next step might be or predicting certain outcomes. Is it a good idea to take a crack at machine learning to see if you are missing some signals?
If you have the data and you have the historical data, I mean, it's all the data is what matters, right? And having it be correct, and so that you can get erroneous signals as well, right? So if you have not complete data or data has some outliers in it, maybe it could see something. So I think it'd be definitely wise to explore that route if you have the data and you have those questions you really want answered and you want to take kind of your everything to the next level. Definitely, I think a wise.
Yeah, if you've got the data, you've got the permission to use it, you've got some unanswered questions, machine learning can definitely help you out.
Yep, it can be that next step.
And you can start slow. You don't have to just.
Yeah, you don't have to do it all.
You don't have to hire a 20-person data science team.
No, right.
You can reach out to us. You can read some more stuff. You can do a lot of this stuff online, like right within, for example, like BigQuery does machine learning right within the SQL.
Right.
You don't have to spin up clusters of computers like the old days, let's say. That's all taken care of you. You just ask it what you want to predict, feed it the data, and it'll spit out what it can.
Easier than ever, right? There's so many tools and platforms now that are diving in, or you can even use pre-trained models from some of the others, right? And you can then kind of train it with your own data, but like you can use a lot of stuff that you don't have to build from scratch any longer.
Yeah, that's for sure.
All right, well, next steps. What do we?
Yeah, we have some additional resources powered by these QR codes. So give these a scan. We have a data science webinar by our colleague Christopher Wilson, and he goes through his journey of learning about machine learning as well.
Cool.
Really good webinar for someone that wants to know a little bit more. We've touched on a few of the models. He touches on some more of them as well. And then Luca, one of our senior data scientists, he wrote a blog post on really the power of data science, which is what we've been talking about. Like if you've kind of plateaued with your brain and your ideas and your data analysis techniques of whatever you have in your data warehouse, try using data science and machine learning to see if there's some hidden signals in there.
Right.
That's really what it's about. So, well, this has been a fun topic.
This is, yeah. Until we get replaced. But yeah, I don't know. We'll see what happens.
But I think, like, we talked a lot about we asked the questions up front and the answers came back and then we explained them a whole lot further. Like,
well, yeah, what are we going to do with those questions or those
Yeah.
answers? So that's today and just a chat bot. But yeah, I think humans have our time is still here. But,
we'll be here.
Yeah.
We'll be here next week doing another one.
Yeah. Well, till next time, thank you, everyone.
Yeah, we'll see you later. Have a good one. And if you have any comments or suggestions of things you want demystified, leave them in the comments below or reach out to us and we'll tackle them. See you later.
Bye.